Hello and welcome to Chaos and Caffeine, episode 25. Today is going to be quite interesting. We're going to give some previews on the brand new Empower Vibe, which is our vibration analysis tool, as well as some of the new features of the Empower MCSA. Now, this does not include the empath stuff, which we will cover in a later one, but I don't like to do these commercial ones, but figured new year, new us. Couldn't resist. In any case, it's 2026. Thank goodness 2025 is long gone. Years passed fast, but that was one that definitely was for the don't want to go back and redo it thing. So if you don't know what I'm talking about, well, I don't believe you. 2025 was a little interesting. So in any case, we are going to have a little fun. Today we're going to try the, I wanted to do it last week, but I had the other opportunity. So I had them set up one last holiday Peppermint Mocha for me at the Starbucks on Butterfield Road. So went ahead and saw them this morning, and they had it all set for me. So hopefully it's nice and warm. In any case, then we will cover the two new technologies briefly, and we will go from there. So let's try the eggnog, because I haven't slept, and I'll explain why in a few minutes. Of course, I got a large. What I like about this one, I like peppermint, right? So peppermint and mocha, right? So there's a little bit of chocolate in there. So chocolate and peppermint. Not overpowering. I've tried some other ones. So this is a thumbs up. I cheated a little bit, and I had one of these earlier in the week for New Year's, because I was going to talk about it last weekend. And good thumbs up. It's a foofy drink, which means it's not my usual black coffee, which I far prefer. So let's get into the fun. Now, I'm going to show you what we are releasing next week. Right now, we are in the, hence no sleep. We're in the last bit of getting the manual together and some definite tuning based upon our field feedback. So we're doing that, and then we will be testing it the next couple of days in the field on large machines. So some small ones, but some DC and large power generator, and a couple other things. So that would be our vibration technology. Now it's a single channel, and it meets all kinds of ISO, IEC, and IEEE standards, because we are mapping everything to standards, of course. And, why not? We have a partnership with Hansford Sensors, where they brand the sensors for us. In this case is 100 millivolt per G, and all kind of neat stuff. We'll have the tear sheet on it in the manual and available for everybody. But let's go ahead. I do have a motor that's going to make a lot of noise that I set up in the office, because I have to run it from the computer. When we get into Empower MCSA version 3, I'm going to just have to open data up, because this microphone and that microphone are conflicting a little bit, which is something we're correcting tomorrow before we ship the first ones out to customers on Monday. So existing customers, of course, get software updates. The Empower Vibe was designed to be very affordable, to work off your laptop or tablet. It is a Windows-based system still. No, we did not make it so to run off your phone. No, we did not make it so anything else. Our stuff does not have to connect to the cloud. It's all built in. Any of our algorithms and our logic engines, we call them logic engines because it's a hybrid machine learning, AI, and rules-based system, and everything kind of looks at everything. So Everybody's out there and they've always felt that you have to go to the cloud for AI or machine learning. That's because of laziness. All of our stuff is on premises with the option of cloud, and the reason we do that was really obvious when AWS hit everybody. So in any case, let's not hold on any longer. I'm going to go ahead and set everything up. Then we'll start up the motor in case it drowns us out a little bit. Let's come over here. So this is the front end. I obviously was doing a quick test on a couple of things, but we will go ahead and go through, and we're going to start this from scratch. You can see I have standard measurements. By the way, everything including reporting heads back to ISO 20816 for reporting. In particular, well, because we don't just do motors with this, that's part of the reason why we came up with it. So Empower Vibe, let's get the Empower Vibe. Gotta get the logo back in there. But in any case, this is, I'm running this in developer mode, so it in the end will look just a little different. So here we have basically our acquisition controls, plus it'll change anything over here. When we save data, this is where you want to save it. Nameplate could be there or elsewhere. Your route and everything can be elsewhere. You could do basically overwrite an existing set of data. If the data didn't come out the way you wanted to, you just overwrite and it'll erase the other data. Revision, meaning an update. Timestamp is the default. I can do RMS or peak. When I start collecting data, hit preview, you'll see that here in a minute, and it'll show you the waveform, and then you catch it, and then you get this, of course. You can open existing data or record, and it'll automatically analyze to standards. When I do my speeds and everything else, you can see this here because we're going to run the motor at 50 hertz. And then, of course, any markers we want to do, harmonics or sidebands. There are a few tricks with the version I'm showing you right now. This is actually back 2 iterations for certain stability. But in any case, it'll also go through all of the gates and everything else, which are set up standard, but you can adjust. And then a fault library, which is, that's part of what we're expanding right now. So it's going to have a lot of motor stuff in it and some other things. The additional data, of course, this screen is meant to hold additional things as we move on into the future. As with the Empower MCSA, we have this planned out through several iterations. So some of the dashboard will change a little bit. There is a waterfall capability. We'll show you that. Where I can come in here and I can look at basically select any points that I've collected or all of the points in a folder, and it will do a quick comparison. The settings, we're going to go ahead and start the settings here. The channel will be 0 by default, but I have it set up because we have several options. Let's go ahead. This one is 99.5 is the calibration. You'll also notice that we have ISO 2954 style calibration and repeatability. If you have a shaker, you can actually do your own calibration on the system. It'll update everything in your software even. And then, of course, all of the bands per ISO 28816. And then if I click apply settings, it will, of course, apply them, but I'm going to end up saving that. Where all of my trending data goes, here. And then, of course, this one here is nameplate. There's actually 2 nameplates in this one because of some of the things we're doing, and of course some other stuff. And then any band alarms you want to set in addition to the default. So you can set any additional band alarms, including amplitudes and alarms and everything else, in addition to what's built in to the system. We do have the route capability, and basically when you set up a route, it will walk you through a bunch of stuff. So you create a route, whatever you want to call it. It'll save that. When you call it up, it'll walk you through the points. You can move or fall back within the route. Trending. This is basically going to be primarily in metric, and then we have what we call Step 9 database. This is our own part of the logic engine. It's quite interesting. We'll see if everything works while I go through this. The about still has to be cleaned up now. So that's the primary thing. So let's go ahead and set up a machine. So we're going to go ahead. This is don't want to show off too much of my computer. But in any case, yeah, so this is version 1 when we come out. And there's a few extra things that are going to be in here, band alarms and all of the levels and all the other stuff. And we'll go through the standards afterwards because standards are boring. Just ask my intern. Now, this system here, the data collection system, I worked on with our intern. This was part of a project he was doing while I had him working on his level 1 for vibration analysis. And let's go ahead and we are going to save everything into a new folder. And it is 2026 103 lab. Okay, so I've set up a folder. I'm going to select that folder. Okay, you can see everything went away here. I am going to call this lab motor. Okay, and we're going to go ahead and do that in metric. You can do it in inches per second and RPM if you want. If you save it, then all of the data that happens in acquire and additional, which is the displacement, will be in English readings, although the analysis, because we're following ISO standards, will be in metric. So here's those gates I talked about. So if you want to make any changes to the gating, there you go. It's all set. Okay, so once we set that up here, we go ahead and I'd already saved this. So we are going to save this. There you go, saved into there. The next thing we want to do is a setup wizard, and that is going to give me a couple of things. So lab motor, VFD, it's on a VFD, motor dock, and my office. Okay, so it's a direct drive, it's a motor, and we'll just say other because that's all it is. And then driver nameplate I can put in here, let's say 1 horsepower, 14, and you can see there's something there. There is on the final version, there's rotor bars and stator slots. For this first version, just like with the Empower MCSA, we have not tied it to our motor database yet because we are expanding that database. So that database will be out with the next iteration during the first quarter. It's a big improvement. It's covering some metric and some new motors. 230 volts. We will say 2.4 amps and 50 hertz. Okay, so we do that. The bearing part here, you can see there's some stuff, but the bearing part, this is already in the final version tied to the bearing database, the same one we use for the Empower MCSA. And then what points there am I going to take? Well, obviously we're going to not do any. Okay, so once we're done, we finish and save, and it updates that machine. So I now have that all set up. So now I'm prepared there, and back here we want to save it. to the correct folder. There we go. Hit select. And we are all set. So timestamp, we will do peak. Okay. Everything's been saved. We're saving it into that location. I can change this to whatever time I want. I've got the default for the software is 30 seconds for this type of data collection. And then for root data collection, it's 10 seconds per point. So let's go ahead and I'm going to start up the machine. You'll hear it. It should be noisy. Or it might not. I don't know. I haven't tried this with this microphone yet. And this is a small, well, relatively small room with a very, very noisy motor and drive, which are all set up incorrectly, deliberately. Wait till it gets up to speed. Okay, so we will say, yeah, we'll leave it at drive. It's actually opposite drive end, non-drive end horizontal. I have it mounted incorrectly just because I haven't set this motor up for this kind of thing. I just grabbed it because that's the way it is. We've been testing on a metal motor and a special piece of equipment that I keep in here. Okay, so when I do collect data, there we go. Make sure my settings are correct. Yep. Okay. So here we are. You can see because on a VFD, it's probably going to give me some interesting warnings. But now I see it's kind of stabilized. Let's go ahead. We'll record it and analyze. You can see I have a time thing pop up here. And that is because, you know, whenever something's collecting, it feels like paint is drying. And I'll count down from whatever the time is. Two, one. Then it takes a little bit for it to process because it's going through the logic engine. Let's see how it turns out before I turn the motor off. Yeah, I can see the microphone's doing a little bit in the background, so. There we go. So here is my data. There's my time waveform. There's everything else. There's all the noise from the VFD. Now this is actually a little bit of aliasing. That's one of the artifacts that we're dealing with before we ship. Oh, thank goodness. That is so annoying when it's in this little tiny room. In any case, so there we go. Now it's popped everything up. Part of it has also gone ahead, and anything in here I could go, yeah, I don't like that. The first one here is going to show me all of my gates. So it passed the quality test and everything else. So basically, it provides me information to tell me whether or not my data was collected right. So somebody out there collecting data, if I have the scroll bar, if it's a smaller screen, they'll be able to see all of that stuff. And then down here, it says, okay, it's within moderate level of vibration. So 1.6 millimeters per second, and that's not surprising. This thing is developed with a couple of problems. It's not picking up the bearings yet because I have shut that off for this one. And then we will have it, we do have it in the final version. So if you put in bearing information, which I did not do, it will analyze the bearings. If I put in rotor bars and stator slots, it's going to analyze the rotor bars and stator slots as well, including the fact that we are actually out to close to 20 kilohertz. Now, the Nyquist in here, because we were using two, you use two for motor current signature analysis, it did that. The number of averages and everything is built into the software. You don't have to worry about it. My mills of displacement are here. I'm sorry, my whatever meters are here, and you see a little bit of DC stuff hanging about. If I, you notice that it will bounce out here, so I do need to zoom in. I'm working on that artifact now, but I do need to zoom in a little bit in order to get the right peak, etc., etc., etc. And it's going to highlight this. So 24.933 and the velocity peak, it automatically picks up. So that's automatically picked up the running speed. I can correct that, of course, by coming in and actually highlighting the correct speed. It'll correct everything. So if I come down, yeah, and then of course the bin is wide enough that 24.83 because of 30 seconds. In any case, neither here nor there. Harmonics, let's see, let's see if it works. Harmonic peaks, if I come up here, it will automatically, when I select it, it's going to give me 10, and it'll give me all of the locations in hertz. And then sidebands, it will do sidebands as well. Pick one spot, pick the next, and it's going to go out to 6 in both directions. And it will also map that, and it'll tell you what it is. So this is by point. And then the waterfall, let's go ahead. I am going to go to a set of data that I had taken previously. I believe this is it. And let me see, let me make sure that's it. Yep, that's it. So we're going to go ahead and just add that whole folder. So selected the folder. You can see here's where all of the information is. And then I'm going to go ahead and plot. So I don't know what, I was doing all kinds of weird stuff with this particular one while we were testing a few things. So this is my in-office cleanup stuff while I'm testing everybody's input and software additions. Of course, because I'm running this, hopefully it doesn't cause any lag. There we go. So here we are. It's got a couple of sets from here, from this motor when I pre-tested it earlier today. You do notice, I believe out here, I should be able to change my Fmax. My Fmax actually goes out to as high as 20 kilohertz. Oh, I dropped that button off for some reason. We will get it back. In any case, so we are here. Oh, and of course, if I want to adjust anything, because this is cool, and it'll have its own report. Zoom just zooms in and out. If I want to come in and get in closer or have the data expand out so I can look at anything in particular that's there. And then of course I can, if I select any of these others, I have to replot and it'll change it to acceleration or displacement. So that is kind of it in a nutshell. Not too bad for a quick, easy, single axis data collection system using straight ICP systems. We have a lot more coming up this year. So let's go ahead and we are going to exit out of this. And let's take a quick look at what you have in store for the other thing that we're just kind of cleaning up today. So I'm going to open existing motor just because conflict with the microphone. So let's go ahead, new analysis. Oh, my bad. I'm sorry, open analysis, what I meant to do. So let's go ahead and we are going to go ahead and open random machine. I don't want a random machine. Let's see. This might work. Let's do one better. We're going to do one better. I'm going to cancel out of this. We're going to, yep. We're going to open one. I'm going to get some real data. So let's go ahead and let's grab this one, and we want this one, we want this one. So a return fan, air handling unit, because this is one of the ones I tested, so I'll be able to show you some of the stuff we have in here. Okay, so it's going to take a few seconds for it to catch up, and then I'm going to focus primarily on the new feature. You notice this here, it says motor life inputs. This is key. This is kind of neat. I've taken basically 40 years of experience and we're pumping it into both. The vibration system over time is also going to meet some of these new standards for remaining useful life and all the other work we have going on. We're building that now into here. So here's my machine. What I've done is, so this is a nameplate. It's about a 60 horsepower machine. Took it just over a year ago. Now here it is. So this is the original OEM type stuff. Any history I have becomes very, very important. Whatever I have for lab data, if I don't have anything, just leave the whole thing blank. It's going to default to a database that we have attached that is based upon IEEE series 486 and let's see, 493. IEEE 493, 1415, and another series. So, here it is in the manual. So, in addition, 1415, the IEEE 3006, and the 493. So, that's all part of the data that we have in addition to the work we've been doing on standards as well. So in this case, we would select whatever the actual insulation resistance, the insulation class is from the original. This will default to 120,000. That's laboratory life. And then certain other estimates. The accelerated temperature was 220 degrees. The ambient temperature where this motor is 20 degrees or 19, either one. Humidity the same. Contamination level medium, meaning in factory environment. Vibration medium, meaning that there's a lot of motion nearby. What is its estimated load factor, design load factor? It's going to estimate off of the actual loading and so on, etc. If I know the number of operating hours and I know how many hours on average it runs per year, I don't need to be exact. Remember, this is what's called a rule. Okay, so I have all this information. Now let's go ahead and we are going to run the auto analysis. Now it's going to take a few minutes for it to run. It's doing the logic engine. And then you notice a couple of new things here, but big one is going to be this predictive button. Now it's hunting the speed, the actual speed, because the thing was on a variable frequency drive. We do have certain other capabilities. I'll talk about those next. You notice the license status. So we can release these. If there's a loaner or anything else, we can give any length of license that we want. And there's a reason for that on certain things. I have a feeling that it's hanging up primarily because, let's see, where are we? It's working. Slowly, there it goes. I think just doing something freed up the computer. So just like before, all the stuff there, check rotor bars, ODE bearing defect, but if I want to take a look here, you notice it'll give me an overall risk analysis. Now this is done to ISO 13374, which is the condition monitoring diagnostics architecture. We've mapped it to everything, including severity. The ISO 13381-1 for prognostics and remaining useful life. The time to failure estimation, that's ours. That's based upon work that I published in the early 2000s through IEEE. IEC 60812, failure modes and effects analysis, because why not? It's provide. You'll see it's going to provide certain information. Of course, ISO 20958, which is electrical signature analysis of induction motors, includes motor current signature analysis, and then IEEE 1415, which I chair, a bunch of ACP, American Clean Power, and IEEE 493, IEEE 3006 for all of our stuff, and and a lot more on the way. Sorry, I spent a lot of years working on standards. I know what they are, know how they work. We've incorporated them, and we've gone another step where we're actually analyzing stuff. So to get this moving, let's go ahead. We're going to hit the predictive, and here we go. So this particular machine does have an issue, so it's providing information on the ID location. The relative harm index is going to be in version 3.1. That was a little more complicated. So that and the power quality score are going to be based upon current only. Risk band is high because it's above, comes out to be just in the high range. Mechanical store is about 2, and that has to do with bearings. And time to failure estimation comes out to be about 2,100 days, 2,100 hours, I should say, for the remaining useful life. I'm seeing 1,658 hours. So when I look at these, it's going to select the lower value based upon us wanting to be a little concerned. Dominant failure mode, unknown motor life here, and then this gives me a basically risk of failure and then a resistance to failure. So the band here is my resistance to failure. It's at a relatively high risk of failure because of its condition. Okay, and then it's got this stuff here, and then we will get into some other information here. So oh, there it is. Okay, so down here in the lower part, you can see the equipment name. This is the report. Dominant pattern detected, rotor bar and motor circuit, electrical indicators, mechanical indicators, and then basically how did it come up with this? Why did it come up with it? So all of the information explaining why, and then including the where it is in relation to noise, because it was a relatively noisy signal. The overall losses, so 97 watts of losses, immediate losses, not the kilowatt hours. So that is actually not a great indicator. We'll go back to that in a second. So it comes in and it says why it selected rotor bars and stator slots, made recommendations on what to do, like what to check. This comes off of a lot of calls we get saying, hey, I'm seeing this. How do I verify it? Well, we went ahead and built it into the software. So it's going through and it's analyzing and saying, okay, it's this type of system, it's this situation, everything else, and it's providing all of the recommendations and then next steps on how to prioritize it. That all prints as a report. that you can access, and all of this information, including this and the bands having to do with electrical or mechanical, pop up. So to tell me, okay, uh, say I have a limited amount of time to do something. Do I have primarily an electrical related issue or do I have a mechanical related issue? And here's the description. What do I focus on? All of that is there to help. This also has some specific information on what the possible reasons are for the conditions. So that is that. So if we come here and we say, okay, what the heck is going on? And here it is. You can see 96.8 watts here. Now, if I have put in my nameplate number of hours of operation and the cost, electrical costs have obviously gone up this year. Darn you, data centers. Can't complain too loud. We're starting to make something off those too. So here you go. So the energy opportunity, not a lot. Emissions, not a lot. Half a ton of CO2 and stuff like that. So I have a feeling, unless it's a critical machine, it will get priority. So all that decision making is put in here. Now, here is one of the big things we did. We have a lot of companies, including wind and everything else, that can grab data remotely. We have a bunch of other stuff like that. So import CSV gives me the ability to take off of anybody's instrument. Let's go over here. I'm going to grab a specific set of data I shouldn't show there. Let's go ahead in here and we are going to open this one. Okay, so it's going to grab that data. I want it to be current. So there's my current for this particular piece of equipment. And then this is for 100,000. That was a default for a specific client. This is actually at 10,000 samples per second. I want to do that. It's going to save it as a file that I can read. So here we go. We have now saved it. Now, assuming I put the nameplate in, this one I know has a very specific problem for those of you who are doing wind work. So whether I'm taking data directly from wind or I'm using this, it all comes out. So here's the information. There we go. And then let's go ahead and open up that analysis. Is what we've been working on. I know some people, it doesn't look like a lot. It's a lot of work. So there we go. Our specific data auto-analyzed for those who are in the wind industry. Of course, this is going to lag just a little bit. We'll give it a chance to pop up here. One of the big issues that people have to do with the wiring. We have specific training for wind industry on how to detect wiring issues with our technology. We don't make that generally public because everybody else keeps copying us. Oh, why give this away too? I'm sure somebody's going to copy us at some point. So here we go. Wiring F, meaning that needs to be dealt with. There's very specific things going on here. And actually, this should not be showing up there, but that's neither here nor there. So we also have some things going on with the bearings in the generator. So that's it. That is this stuff that's new. I'm going to have more stuff coming. I don't want to go too long today, but this is all basically coming out in a couple of days. So we're making it. We're making the announcement on Monday. I got some manual updates that might postpone the release a couple of days, but we are right there. So the vibration manual definitely needs a few updates. So if you have any questions, reach out to us. Again, I don't normally do a commercial one, but I want to show you why I'm excited about 2026. 2026 has got a lot coming. We have already received orders. We have materials coming in that cover those orders, and I'm already putting out the next order to restock yet again. This is a good thing, and we're excited, and we ship this stuff worldwide. So thank you for listening to my first and hopefully rare KS and Caffeine commercial version. I mean, after all, MotorDoc and MotorDoc AI and our subsidiaries all cover this podcast. So thank you very much. Happy New Year. Hope you all had great holidays. It's time to get to work.